Most people think software projects fail because of bad code, because the developers weren't good enough, because the architecture was wrong, because the system had too many bugs. That's the story we like to tell ourselves. It's clean, it's technical, it's controllable. If the code is better, the project will succeed. If the engineers are smarter, the outcome will improve. If we just choose the right framework, everything will work. But in reality, most software projects fail long before the code becomes the problem. They fail in conversations. They fail in assumptions. They fail in planning documents. They fail in meetings where no one asks the uncomfortable question. And if you understand why that happens, you're already thinking like a software engineer, not just a programmer. Today, we'll break down the real reasons software projects fail and what good teams do differently. Not theory, not motivational slogans, but structural patterns that repeat across companies, startups, enterprises, and even open source projects. The misconception. If you're learning programming, it's easy to believe that writing correct code is the main challenge. You focus on syntax, algorithms, data structures, performance, design patterns, clean abstractions, and those things matter. They absolutely matter. Technical skill is not optional, but in real-world software engineering, the hardest problems are usually not purely technical. They are structural. They are organizational, they are human. Software is not just code. It is a system made of people, communication, constraints, uncertainty, incentives, trade-offs, and yes, code. When that larger system breaks down, the project fails, even if the code is technically fine. You can have beautiful architecture and still ship the wrong product. You can have 95% test coverage and still disappoint users. You can use the best tech stack and still miss the market. Let's look at the real failure patterns. 1. Unclear requirements. This is the most common failure point, and then it happens at the very beginning. A stakeholder says, "We need a dashboard." The developer asks, "What kind of dashboard?" The answer, "Just something simple." Simple to whom? A marketing dashboard? A real-time analytics dashboard? An admin control panel? A financial reporting system? An executive overview with 3 big numbers? A drill-down tool with filtering and exports? If the team does not clearly define what problem is being solved, who the user is, what success looks like, what constraints exist, what is explicitly out of scope, then they are building on assumptions. And assumptions are dangerous. Here's what usually happens. The developers build something that makes sense to them. It technically works. It even looks polished. The stakeholders expected something else. The mismatch is discovered late, maybe at a demo, maybe right before launch. Now the team has to rework large parts of the system. Or worse, they try to patch the mismatch with quick fixes. That costs time. That creates frustration. That erodes trust. And often, that's where the project starts sliding toward failure. The deeper issue is this. Most teams start with solutions. Very few start with problem definition. Avoiding this requires discipline. Before writing code, clarify goals. Define scope. Write down acceptance criteria. Align expectations. Put examples in writing. Define what done actually means. Software engineering starts with understanding, not coding. 2. Scope creep. Even with clear initial requirements, projects often expand uncontrollably. It starts small. Can we also add user profiles? Maybe notifications too? Let's support mobile as well. Could we integrate AI? What about multi-language support? Each addition sounds reasonable. Each one seems small. Each one is justified. But software complexity grows non-linearly. It doesn't grow by addition. It grows by interaction. Each new feature adds interactions with existing features, increases testing surface, expands maintenance burden, raises architectural complexity, introduces new failure modes, creates more edge cases, and complexity compounds. If the team does not actively manage scope, the project slowly becomes heavier and harder to move. Deadlines remain fixed, complexity grows, quality drops, morale drops. Eventually, the team feels like they are running through mud. Scope creep is not about adding features. It's about adding features without removing anything. Great teams understand subtraction. They ask, what can we remove? What is essential? What creates the most value? Good teams fight scope creep by prioritizing ruthlessly, delivering in small increments, saying not now to good ideas, protecting focus, making trade-offs explicit, measuring impact before expanding further. Simplicity scales, uncontrolled expansion does not. 3. Communication breakdowns. Software projects are communication systems. Code is just one layer. Consider how many communication channels exist in a typical project. Developer to developer, developer to product manager to stakeholders, QA to developers, DevOps to everyone, designers to engineers, support to product, leadership to teams. Every misalignment creates risk. If product misunderstands technical constraints, they promise unrealistic features. If developers misunderstand business goals, they optimize the wrong thing. If QA is not involved early, critical use cases are missed. If leadership hides risks, surprises explode later. If remote teams lack context, decisions diverge. Most major bugs are not caused by syntax errors. They are caused by miscommunication. Something was assumed, something was implied, something was never clarified, something changed, and no one told the team. And here's the uncomfortable truth. Communication problems rarely look dramatic. They look small. A skipped meeting, a vague ticket, an undocumented decision. But over time, those small gaps accumulate. Strong teams invest heavily in documentation, code reviews, shared definitions, regular feedback loops, clear ownership, transparent decision logs, early demos and prototypes, because clarity prevents collapse. 4. Lack of technical discipline. Even with good communication and well-defined goals, projects fail if engineering discipline breaks down. This often happens under time pressure. Deadlines approach, shortcuts feel justified. Testing is postponed, code reviews are skipped, refactoring is delayed, monitoring is ignored. Just this once. And gradually, the code base becomes fragile. Now, small changes break unrelated features. Developers become afraid to touch certain modules. Onboarding new engineers becomes slow and painful. Build times increase. Deployment becomes risky. Technical debt accumulates. And technical debt is not just messy code. It is accumulated friction. It is slowed velocity. It is rising risk. Eventually, the system becomes so unstable that adding new features is painful. At that point, the team slows down dramatically. And management often misinterprets this as poor productivity, when it is actually structural decay. Technical discipline includes version control best practices, code reviews, automated tests, continuous integration, continuous delivery, consistent architecture, observability and monitoring, documentation of decisions. These are not luxuries, they are structural supports. When removed, collapse becomes likely. 5. Unrealistic deadlines. This is one of the most destructive forces in software projects. Software estimation is inherently difficult. Why? Because building software involves unknown edge cases, changing requirements, integration challenges, human coordination, legacy constraints, external dependencies. When deadlines are set based on optimism instead of evidence, pressure builds. Under pressure, teams rush, testing decreases, documentation disappears, architecture suffers, burnout increases, corners are cut quietly. The result? Short-term delivery at long-term cost. And here's the dangerous cycle. Rushed work creates technical debt. Technical debt slows development. Slower development increases pressure. More pressure causes more shortcuts. This loop kills projects. Healthy teams break work into small increments. Re-estimate frequently. Communicate risks early. Accept trade-offs consciously. Protect sustainable pace. Use data instead of optimism. You cannot eliminate uncertainty in software, but you can manage it. 6. Lack of ownership. Another common failure pattern is diffusion of responsibility. Everyone is involved, but no one is accountable. When something breaks, the question becomes, whose job was that? When priorities conflict, no one has authority to decide. Ownership does not mean control over everything. It means clarity. It means knowing who decides, who executes, and who approves. Teams that succeed define clear ownership, product ownership, technical ownership, operational ownership. Without it, coordination slows down and problems linger. 7. Ignoring feedback. Sometimes projects don't fail because of internal issues. They fail because teams ignore reality. Users give feedback. Metrics show low engagement. Support tickets reveal confusion. But the team continues building according to the original plan. Why? Because changing direction feels expensive. because ego gets involved, because sunk cost bias is powerful. Successful teams treat feedback as data, not criticism. They iterate based on evidence. They adjust. Failure often happens when teams become rigid. The deeper truth. Software projects fail because software is a socio-technical system. That means it is part human system, part technical system. You cannot fix communication with better syntax. You cannot solve unclear requirements with a better framework. You cannot compensate for unrealistic expectations with clever code. Software engineering is not just writing programs. It is managing complexity across people, processes, and code. And beginners rarely see this, because when you are learning to program, your world is small. One file, one computer, one goal. But real-world software involves teams, users, deadlines, budgets, legacy systems, compliance requirements, changing markets, long-term maintenance. Understanding this early changes how you think. How good teams avoid failure. Now let's talk about solutions, because projects do succeed, and they succeed predictably. Here's what successful teams do differently. They clarify before they code. They define user stories, acceptance criteria, edge cases, constraints, non-functional requirements. They ask uncomfortable questions early. They write examples. They prototype. They test assumptions. They define metrics for success. Ambiguity is resolved before architecture is written. They work in iterations. Instead of building everything at once, they deliver small increments, gather feedback, adjust, repeat. This reduces risk. It exposes misunderstandings early. It creates momentum. It keeps stakeholders engaged. They invest in engineering discipline. They review code, maintain test coverage, refactor regularly, keep architecture clean, automate deployments, monitor production. Not because it is idealistic, but because it reduces long-term friction. They expect change. Software is never finished. Requirements evolve. Users discover new needs. Markets shift. Technology changes. Good teams design systems that can change safely. They prioritize maintainability over cleverness. They optimize for adaptability, not perfection. They communicate constantly, clear documentation, shared definitions, regular meetings, transparent roadmaps, open risk discussions, postmortems after failures, because alignment is more important than speed. Final thoughts. So why do most software projects fail? Not because of bad programmers, not because of poor frameworks, but because complexity is underestimated, because communication breaks down, because discipline erodes, because scope expands, because deadlines ignore reality, because ownership is unclear, because feedback is ignored. If you understand this early, you avoid one of the biggest traps in software engineering, believing that coding skill alone guarantees success. Real software engineering is about managing change safely. It's about building systems that survive growth, pressure, and uncertainty. It's about thinking beyond code. And if you're learning software today, start thinking this way now. It will change how you approach every project. If you want a structured next step after this video, I've linked a beginner-friendly software engineering learning path on Coursera in the description. It's a guided way to build the foundations, programming, workflows, and how real projects run, without having to guess what to learn next. If this video changed the way you think about software, even slightly, that's a win. Most people focus on code. Very few step back and look at the system behind the code. If you want more videos like this, breaking down how real software projects work, how systems fail, and how to think like an engineer instead of just a coder, consider subscribing. I publish deep dives on software engineering, architecture, and the hidden structures behind technology. And if you found this helpful, click the like button. It genuinely helps the channel reach more people who are trying to learn this stuff the right way. If you've worked on a project that failed, or one that succeeded, I'd love to hear what made the difference. Leave a comment below. Thanks for watching. I'll see you in the next one.